Hi, this tutorial will teach you how to apply these two equations in problems changing from, let's say, from a solid to a gas at a different temperature. So let's say we use water H2O as an example. If we have an ice cube and it is initially at -10 degrees Celsius, and we would like to change this ice to steam at 120 degrees Celsius. So is this just a simple transition? If we want to calculate how much heat is required to make this change, what should we do? So we're going to look into this simple process, which we will find out that it is not that simple. So we have these two equations. And remember, if there's just a change in temperature, we will use mc delta T. If there's a change of state, we will use Q is equal to NH. But now, as we look at here, you can see it's changing from ice to steam. And the temperature is changing from -10 degrees Celsius to 120 degrees Celsius. So there's a lot more embedded in this statement. So we have to look closer to what is going on right here. So we will start off with the ice at -10 degrees Celsius. And now let's think about this. If I want to have ice changing to steam, now just think about it practically using your common sense. Does it have to go through something else first? Of course, it has to change to water first before it becomes steam. So we have to take this into account. So ice must change to water first. So at what temperature would ice change to water? Well, it's at its melting point. So it's going to be at 0 degrees Celsius. So we have to go to 0 degrees Celsius first. But we can only change one thing at a time. We can either change temperature or change state. Now in this case, we cannot change ice to water at -10 degrees Celsius because it's below its melting point. So if for ice to change to water, we must bring the ice to 0 degrees Celsius first. And then at the melting point, we can change the state from ice to water. Okay? And now, let's think about this. We now have water, and we want to change it to steam. Then we have to think about at what temperature would water change to steam? Water would change to steam at 100 degrees Celsius. So that means we have to somehow raise the temperature to 100 degrees Celsius. And this process will not change the state. So it remains at water, at liquid state. And then, once we change to water, we can now change, well, once the water is now at 100 degrees Celsius, we can then change the state because it is now at the boiling point. So we don't expect to see a change in temperature, but we will see a change of state. Okay, it is now steam. And then for the last conversion, it will be steam at 120 degrees Celsius. So as you can see here, from going from ice to steam from -10 degrees Celsius to 120 degrees Celsius is not a simple process. It takes 5 different steps. Each arrow here represents a calculation because it represents a change. So if we look at the arrows, so at the very beginning we have a change in temperature. So we have Q is equal to mc delta T. Okay, we'll use the other color for the next one. Here we have a change of state from ice to water, and there's no change in temperature. Q is equal to NH. And now, which H do we use? The molar heat of vaporization, or do we use the molar heat of fusion? Well, since it is a change from solid to liquid, we're going to use the fusion. Okay? And then we move on. We have a change in temperature. So Q is equal to mc delta T. And next one, we have a change in state. So Q is equal to NH. In this case, since we're changing from liquid to gas, we have H of V, the molar heat of vaporization. And for the last one, it is just a change of temperature of steam from 100 degrees Celsius to 120 degrees Celsius. So it will be Q is equal to mc delta T. Okay? In the next part of the tutorial, I will show you how to calculate from here, from -10 degrees of ice all the way to the steam. I will actually put in numbers and you will see how to calculate it. And there's something that you have to be aware of while you're doing these calculations.